So today we're going to be talking about volume and how solids can change the volume of a liquid. So I'm going to add Coke to this cup. I'm going to fill it up as high as I can. Now when I add this ice, can anyone tell me what they think might happen? Yes, you.
I feel like when you put the ice in it, the ice is going to put some space in it, and then some of it will go on the
You
outside
think?
around it.
Does anyone else agree?
Yes.
Yes? All right, let's find out. So when I add this, it overflows, right? So it overflows out of the cup. And can I drink this now
No.
without spilling it everywhere? No, I've added way too much. I've added way too much Coke to or ice to it.
That's why you
Okay.
put your ice in before you cook.
That's why you put your ice in before the Coke, so you already know how much to put in there. All right, so now I'm gonna have you guys go back to your seat quietly. Remember to go quietly. Go ahead and have your pencils ready. All right. So today I told you we're talking about liquid and volume, right? So how we're going to measure a solid's volume by measuring the liquid. So our learning goal for the day is I can measure liquid to find the volume of objects. Okay, now I'm going to have you guys read it with me. Ready?
I can
measure liquid to find the volume of objects. Let's read that one more time because we were kind of jumbled, okay? Take your time. I can measure liquid to find the volume of objects. Okay, so we have this is called an anchor chart up here. Okay, you guys know because you have anchor charts all over the wall, right? So when I pass this out, I don't want you to do anything but put your name on it. Okay, don't do anything but put your name on it. Basil, will you pass some of these out for me to this side of me? I'm going to go and pass some out here. That's it. So what are we going to be talking about? Just by reading our learning goal, what can you think we're going to be talking about?
Measuring liquid.
Don't call it out. You're right, but don't call it out.
measuring liquid.
To find the what? What are we trying to
The
find?
object.
The object's what?
The object's. The volume.
The object's volume, right? Okay. So does everyone have a paper? All right. So these are called guided notes. And you guys will follow along and fill in the blanks that we have off of our anchor chart. Okay, it's not going to turn off. Okay, so we're talking about measuring liquid, right? To find the volume of the object. So we have to know capacity, okay? Just like the cup. The maximum amount, capacity is the maximum amount something can hold, right? So we know the cup held only so much Coke, and when we added the ice, it did what? It overflowed. Okay, we overflowed the capacity, right? We put too much in there. So you guys should be following along as we talk about it. So the capacity is the maximum amount something can hold. Make sure we're all right. So in a box over there, yours is set up exactly like the anchor chart. In the box, it talks about the capacity of this water bottle, which is a smart water bottle, is 1 liter. When it is full, there is 1 liter of water in it. So that cup, if that cup was 1 liter, it held 1 liter, right? Okay, and it only held 1 liter. No matter how much Coke I put in there, the cup only held 1 liter. Okay, now we're moving on. Liquid volume. Liquid volume is the amount of space a liquid takes up. Okay, so the amount of space the liquid takes up. Make sure we're writing. Dalton, make sure we're writing. And then in the box it talks about the liquid in this container has a volume of 30 milliliters. Okay, and on here it has little dash marks on this container. And on your container too, you can you can see the little white lines. Your white lines, mine's white lines, yours is white lines. Okay, each one of these little lines equals 10 milliliters. So if we go up, we'll 10, 20, 30, help me out, 40, 50,
60, 70, 80, 90,
100. So that's 100 milliliters. Okay, and when we get to the graduated cylinder, okay, when we get to our stations, you guys will know. Okay, so let's make sure we've all got our notes. You're missing something. I'm making sure we're writing it down. This is what you're gonna look at when you need to refer to. If you get lost on anything. Okay, guys, make sure Jaden did a really good job of writing down her notes. And she was able to read it. It was neat and she was able to read it. So make sure it's neat so you can read it. If you need help later throughout this lesson, you can refer to your notes. If you can't read it, it's not gonna help you at all. Okay, and then go a step down. It says we can use liters, which is represented by a capital L, an uppercase L, and milliliters to measure amounts of liquid. Okay, so 1,000 milliliters. So these little marks right here, 1,000 of those, okay, now that's in 10, so it'll be 100, equals one bottle of smart water. And just to help you guys out. Remember, when we're thinking of 1 milliliter, we need to think of only one water drop. Okay, one water drop. When you think of a carton of juice, when you see a carton of juice, you need to think of a liter, 1 liter. Let's make sure we've got them all down. All the plates should be filled. Keep your water bottle. Good job. That's very neat. All right. So now I'm going to bring out my cups of water. So this is where we will talk about measuring. I'm going to move this to the back table, and I'm going to hold them up for you guys to see. So we talk about how do we know how much water is in this cup. Okay, and I made some marks based off our graduated cylinders because we just didn't have enough. Okay, so I'm gonna hold up these two. We said 1 mark equals what? 10 what? Milliliters, right? So 1 dash mark, 1 little line equals how many? 10. Can't forget our units of measurement, okay? Don't forget that. Okay, so 10 millimeters. So if I were to pass this around, I'm not gonna let you guys pass it around, but if I was to set this on a desk, how many milliliters would that be? 10 milliliters, okay? Because it's at the very bottom mark. At 10 milliliters, it's at the first mark. So this next one I have, that I'm gonna use for y'all. Now this one only has how many marks? 2. So that's kind of a hint right away, right? There's only 2. So how many milliliters is that? 20. How did you guys figure that out? Don't call out. I want to call on somebody. Zero.
You can count by tens.
Count by tens. Or you can, what's another way?
You can read the lines and just think of it as 10 milliliters every line.
Every line, and you did 10 milliliters plus 10 milliliters. There's one more way that you guys haven't thought of, and it starts with an M.
Multiply?
You can, yes, Basil. You what?
Multiply.
What did you multiply?
2 times 10.
2 times 10. And why 2 times 10? Don't answer this, Basil. I want someone else to answer it. Abby, why do you do 2 times 10 on this one?
Because it's 2 and then each of them equals 10.
Right, because it went up to the second line, and each line equals 10, so we know that 10 times 2 is 20 milliliters. Okay, then one more. Okay, one more. Let me walk over here. I want to ask somebody over here. Jaden. How many Jaden? How many milliliters is that?
That's 40 millimeters because there's 3 lines and you can count by tens.
30 milliliters, and you can figure that out because you count by tens. And what did we say our other way is? Can someone else tell me?
Multiplying
Multiplying what?
3 times 10.
Times 10. And 3 times 10, why do we do it 3 times 10?
Because there's only 3 lines and each one needs 10.
and each one equals 10 milliliters, right?
And I
All right, so how can we find the volume of an object if we only have the liquid? Luke,
You can use ruler.
I don't know. You can use a ruler to find the volume of an object, but I want to know how you find the volume of an object when it's in liquid. Okay, I'm gonna help you guys out because we haven't went over this. That's what we're gonna go over in station. Oh, Boone, you think you know?
Graduated cylinder.
A graduated cylinder will help us. Okay, so what did the ice do in the cup? It overflowed, right? When I added it, overflowed. So what did the water do? I mean, what did the Coke do?
It got higher.
It rose, right? The Coke rose up. Okay, so did that make the volume of the whole thing go up? Right. So we figured out, and we'll figure out stations, and I'll be going around and helping you guys out if there are any questions. Okay, when would we use? Let me ask you this question: will we use milliliters to measure a lake? No. And why? What did we say on our anchor chart? What when we think of 1 milliliter, what do we think of? I want to call someone I haven't called on. Here.
One drop.
Say that louder, please.
One drop.
1 drop of water, right? So would it be, could we measure the lake in milliliters? Is it possible? Yes, but it would take us forever, right? It would take us years and years and years, okay? And why would we use milliliters? Why did we use milliliters to measure the water in that cup? Someone I haven't called on. Lucas?
It's just smaller.
Because it's smaller? I don't know. That's not why we used it. Do you know why, Chloe?
Because the lines on the cup
Equal what?
equal like how
Starts with an M. What do we call it?
multiply,
No.
measuring.
No, we are measuring, but what are we measuring by?
Millimeters.
Milliliters, not millimeters, but milliliters. Millimeters we can do on a ruler. Milliliters we use for liquid. Okay, so if this is millimeters, now if I had said liters, would this be measured in liters or milliliters? If each line was a liter, liters, right? Because it tells us on our cup or our graduated cylinder or even our beaker sometimes. Okay, so we're gonna go off into groups. No, I'm sorry. We're gonna self-assess. Okay, so on the yellow sticky note that I passed out before this lesson, okay, I want you to write 1, 2, or 3. A 1, listen to me before you write. A 1 means I do not know this yet. I need more. Okay. Number 2, I kind of know and I kind of understand, but I still have some issues, and I don't understand everything yet. And then give yourself a 3 if you know everything. If you just think you know everything about this, about finding volume of a solid by measuring the liquid. Don't look at anybody else's. You keep your eyes on your own. All right. So now I'm going to pass out the station activities. Now, group 1, you're going to go to station 1. Group 2, you'll go to station 2. Okay, and I don't want you to do anything but put your name on this paper. Okay, I don't want you to do anything but put your name on this paper, and then I'll talk you through it. Lucas, will you pass these out to the other side, please? So during stations, this is where you're going to be adding a solid object to the liquid. Pass them out that side. Don't have one. So we're going to try to find the volume of the solid by placing it in the liquid. Okay, so you have a beaker. You have a graduated cylinder. This is a graduated cylinder. And at each station, you're going to put how much water in the first graduated cylinder. So this first one, I want everyone's eyes on me. Eyes on me, eyes on me. And everyone has one of these, right? All right, perfect. So on this first one, so station 1, you're measuring the solid. But on this first graduated cylinder, I want you to write and fill in with your pencil, shade in, okay, how many milliliters it starts off with before you add the object. So this is the before one. This one, the second graduated cylinder, right beside it, closest to the box. Okay, that is where you're going to add the solid into the beaker. So over here in station 1, I'm going to add this rock to the beaker. You guys will. Okay, you're going to add it in there, and then you're going to write where the water level, you'll shade in the water level on the second graduated cylinder. And if you have questions while you're at your station, don't yell out. Okay, raise your hand and I'll come over there and see if you guys need any help and answer any questions. Okay, and then for station 2, you're going to do the same thing. This is the before. Don't go ahead and shade in. Don't start shading in because you can't read it clearly from over here. But I like that you're paying attention to what I'm saying and filling in the liquid before. So this one's the before, and this one's after adding the solid. Before the solid, after the solid. Okay, so now you may break and go to your stations. Okay, group 1 will go to station 1, group 2 will go to station 2. And you guys can work together. Okay, you can talk to each other.
Is everybody done? No. Wait, we have to color.
That's fine, Bobby. You can sit there. That's okay.
Is everybody done? No? Doesn't look like everyone's done.
No.
You ain't gotta wait till it's all shaded. Are you done too? Okay, just put the rock in. Here's glue. Have you done one? Yeah, it's good too. Okay, then you who dropped it in? 4-3. I did.
Make sure everyone has it recorded before you drop in the solid.
I don't know where it's at. I'm gonna guess like right above 40, like 3. It's in between 50 and 20.
This is section 2. Make sure you have it right. In the box, it tells you what your solid is going to be.
No idea.
Yes, we will switch rotations, yes.
Can I put the switch on?
Huh?
Wait until everybody's done.
Wait till everybody's done. Make sure you're filling out the right station on your activity sheet. You want to fill this out? Yes, you need to fill it out again.
I'm just waiting for it.
Everybody.
All right, guys, you have about 2 more minutes at this station before we have to rotate. We gotta be careful. It's okay. So volume with this on. So you'll do this one. So it's at what now?
46.
46. So that number will go on top.
Minus
46 minus what? What did it start at? So I'm at 40. So then that's how you find the volume of the solid object. You subtract both of them. So you subtract the solid in the water and then the water without the solid, and that's how you find the volume of it. So now you know the volume of the rock. Wait right there. Don't y'all stay. We'll check on this group. Alright, that's fine. So then you're gonna take the volume with the solid and the volume and subtract it. Okay, so you do volume of the solid subtracted by the volume without the solid. And that's how we're gonna figure out what the volume of the solid was.
Can you say it's like 50? It's 50 or something?
No, because it's not 50, it went up.
Wait, I have a question.
Yes, ma'am.
It's 53 and like the first time it's 51.
Huh? You're subtracting 53 from 50, so you tell me.
So it'll be 3.
Right. Make sure to keep it neat. Now, you guys will have to have this for tomorrow.
When I looked at it right here, it's 51. Why was that without the salt?
Okay.
Is everyone
You have
done?
about 15 seconds.
Everybody. Did he get 50? She got 3.
10,
We still got 3.
9,
She got more than me. Peyton got 3. I got 8. I got 3. Yep. I got 3. It's
4,
okay. How'd y'all
3,
get more than me?
2, 1. All right, listen.